All right. Second page at 13.4. We're just going to do this example, and because the next examples kind of take up 2 pages, so we're just going to start with example 2, and then we'll finish at the very end with both. So example 2: find the velocity and position vectors of a particle that has given acceleration and the given initial velocity and position. And so all we're trying to do is we're trying to get back to the initial vector function, and we have an initial velocity and an initial position, and we're starting off with the acceleration vector. So just like above, if I'm starting off with the acceleration vector, I'm going to go ahead and find the velocity vector. I can find v of t, and that's equal to the initial velocity plus the integral from that time of initial velocity, which is 0, all the way up to t of, and then we're going to change, we're going to look at u substitution, or we're going to change our variables from t to u, so a of u du. So now I'm going to go ahead and over here I'm going to substitute everything in. So v of t is equal to, here we just have I plus the integral from 0 to t, and then we're going to have j minus k, and whoa, I'm sorry, I don't know why I said that, of our integral to I plus 6uj plus 12u squared k du. Alright, so let's go ahead and integrate that. So v of t is equal to just I plus, and now we're going to take remember, because, of the rules of integration, I can just take it of each one. All right, so I'm just going to integrate each at the same time. So the integral of 2I is just going to be 2u from t to 0 I plus the integral for 6u is going to be 3u squared from t to 0 j plus the integral of 12u squared is going to be 4u cubed t 0, and that's going to be k. So we did the integration. Now we substitute in our values for t, and this is what we're going to get. I plus 2t I plus 3t squared j plus 4t cubed. Alright, when we plug in the 0, we're just going to get 0, so those are all going to go away. And so we have our velocity function. And again, we can rewrite this velocity function to be 2t plus 1 I plus 3t squared j plus 4t cubed k. And the reason why we're able to do that is because it's I plus 2I. So that's how I'm just going to do 2 plus 1. All right, and then pull out the i's. So that's how I got 2 plus 1. All right. Now, the next thing we want to find the position function. So we're just going to do the same process. We're going to do r of t is equal to whatever our initial position is plus the integral from 0 to t vu du. So we go ahead and we plug in. So initial position would be j minus k plus the integral from 0 to t. Now plugging in my new velocity function, I'm going to have tu plus 1I plus 3u squared j plus 4u cubed k d of u. When I do all this, when I do the integration, I'm just going to get j minus k plus the integral. So let's integrate 2u plus 1. That's just going to be u squared plus u plus from t to 0, or 0 to t, 3u squared is just going to be u cubed. And then 4u cubed is just going to be u to the 4th. And so we're going to get j minus k plus, let me put my I, my j, and my k there. And so we're going to get t squared plus t, I plus t cubed, j plus t to the 4th, k. And then we're going to combine our like terms. So this j, and that t cubed j, negative k, and that t to the 4th k. So therefore, what we have is r of t is equal to t squared plus t j plus t cubed plus, no, whoa, that's I, not j, I'm sorry. I hate how they look similar. T cubed plus 1, j plus t to the 4th minus 1. Okay. And there is your original position function. I'm sorry, or your position vector. All right.